Cosmic Brief, your guide to the universe.
What if every molecule of oxygen on Earth suddenly disappeared for 60 seconds? Not reduced, not diluted, completely gone. For one full minute, the planet loses the gas that fuels fire, supports breathing, stabilizes pressure balance, and quietly participates in thousands of chemical reactions every second. It sounds short, just 1 minute, but physical systems react instantly when a major atmospheric component vanishes. Oxygen makes up about 21% of the air. It is not only for breathing. It enables combustion, supports energy release, and drives oxidation reactions across industry and biology. Remove it, and the first global effect would be combustion failure. Every open flame on Earth would go out within seconds. Candles, gas stoves, furnaces, power plant burners, all extinguished. Fire is not heat alone. Fire is chemistry with oxygen. Without oxygen, flame physics collapses. Combustion engines would begin to stall because air intake no longer supports ignition. Many generators and piston aircraft engines would fail quickly. Next comes atmospheric balance. If oxygen disappears while nitrogen remains, total air pressure drops noticeably. Not enough to explode structures, but enough to disturb pressure equilibrium. Weather micropatterns shift. Air density changes slightly. Sound transmission becomes thinner and sharper because molecular collision behavior changes. Now biology reacts. Humans do not black out instantly, but the clock starts immediately. Within seconds, severe air hunger begins. Panic breathing follows. Around 30 to 40 seconds, many people begin losing consciousness, depending on health and activity. People at altitude would pass out faster. Divers using independent tanks and astronauts in sealed systems remain unaffected because their oxygen supply is isolated. Hospitals become critical zones. Ventilators without feed oxygen become ineffective. Intensive care patients are at extreme risk during the gap window. Chemistry pauses across the surface. Oxidation reactions slow dramatically. Rust formation stops. Certain industrial reactions halt mid-process. High-temperature protective oxide layers on metals stop forming, leaving exposed hot surfaces temporarily unstable. Even the sky would look slightly wrong. Light scattering depends on atmospheric composition. With oxygen removed, color tone and brightness shift subtly. Most people would sense something is off without knowing why. At the global level, sensors everywhere would trigger anomalies. Fire suppression systems would activate without visible flames. Industrial monitors would flag reaction failures. Aircraft warning systems would spike. Then, at 60 seconds, oxygen returns instantly. Now the second wave begins. Any hot ignition source could allow combustion to restart suddenly. Some engines might backfire. Industrial burners could flash relight. Pressure equalizes rapidly, creating sudden airflow adjustments. People near blackout threshold might recover if oxygen returns in time. Plants survive easily. 60 seconds is too short to cause biological collapse. Oceans barely change because dissolved oxygen exchange is slow compared to atmospheric turnover. Satellites notice nothing because orbital physics is unaffected. This is a chemistry shock, not a gravity event. The deeper truth is this: oxygen is not just something we breathe. It is a silent partner in energy, fire, corrosion, sound, and atmospheric stability. Remove it briefly, and modern civilization stumbles almost immediately. The planet would survive, but that single missing minute would become the most studied atmospheric anomaly in history. So here is the final question. Would you rather lose oxygen for 60 seconds or gravity for 5?